Good morning, guys. We are looking at perfect square trinomials today. This kind of piggybacks on to where we looked at the vertex form of quadratics. a perfect square trinomial, the form is still very similar to what we're used to because the standard form of any quadratic is given as ax squared plus bx plus c. What makes a perfect square trinomial unique is that if you take that middle term b and divide it by 2 and then square that result, you should get the exact same value as your a times c. So your leading coefficient on the quadratic term or on the x squared term times your constant should be equal to the coefficient on the linear term, or just the x term, divided by 2 quantity squared. So if we were to factor these, these four right here, they are perfect square trinomials, and these are things that you should have seen in Algebra 1. So if this is not a review for you, or if you've completely forgotten it, don't panic. We're going to see this several more times throughout the course of this set of notes. So looking at this middle term is 8. So if I divide 8 by 2, I do get 4. And then when I take 4 and I square it, I get 16. Well, my value for A is 1. My value for C is 16. 1 times 16 is 16. I notice that my middle term, when I cut it in half and then square it, is also 16. So that indicates that this is a perfect square trinomial. So the way that factors is just going to be x plus 4 quantity squared. That 4 comes from when we cut that middle term in half. You're going to see that again on this next example here on the right, where we have m squared, except this time instead of being something plus something else, it is minus and plus. So when we cut negative 18 in half, we get negative 9. When we square negative 9, we get 81. And we see that 1 times 81 is going to be, let me try this, 1 times 81 is going to be 81. And then when we square negative 9, we also get 81. So those two numbers work out. So that means that this one is going to factor as m. And then remember, we'd use half the middle term. So half of negative 18 is negative 9, quantity squared. Our next example, the middle term is 2. When we cut 2 in half, we get 1. 1 squared is 1. So this term will factor as a plus 1 quantity squared. And then finally, the last example on factoring perfect square trinomials, our middle term is negative 10. When we cut negative 10 in half, we get negative 5. When we square negative 5, we do in fact get positive 25. So this is another perfect square trinomial, and that one is also easy to factor. The next steps that are listed here, we're going from standard form to vertex form. And if you can't factor the given trinomial easily using any of the techniques we've done before, we can use a technique called completing the square. Rather than go through all the examples here or all the steps of how to complete the square, you guys can read that if you choose to, but I would much rather prefer to show you through an example on how that works. So let's just go ahead and we're going to jump into these next examples where we're going to write the function in vertex form, and then we're also going to indicate what the vertex is. So just to refresh your memory, vertex form is a times x minus h quantity squared plus k, where h and k are the vertex of the quadratic. And you can also find those graphically as well, and I'll pull up Desmos on a couple of these to show you. So with example number 1, let's look and see if this is a perfect square trinomial. The middle term is 4, so if I cut 4 in half, so let me just indicate what I'm doing here. Take 4 divided by 2, and I'm going to get 2. And then when I square that, I get 4. And that does equal the constant term that we have. So we know that this is a perfect square trinomial. So that means it will factor as x plus 2 quantity squared, where that 2 comes from half the middle term. So when we look at this trinomial now that it's factored, remember we've discussed this before. If we're missing a term, I think Caleb Pratt put it best when he said it ain't there. We don't have a value for k, so we can always just put a plus 0, and that indicates what our k value is. So the vertex of this quadratic is going to be -2, 0. Okay. The -2, we just take the opposite sign of what is in the parentheses there, and then our 0 is the k value, and so we have a vertex of -2, 0. Now our next example is not a perfect square trinomial, so if we, and I'll prove that by just taking -8 divided by 2 is -4. When I square -4, we get positive 16. That does not equal the 18 that is our constant term. So we need to come up with a different way to factor this. We could look at just doing the AC factoring, but in this case I want to use this as an example of how to complete the square. So we will take this this quadratic, we're going to rewrite it by just putting the first 2 terms in parentheses, so nothing mind-bending there, just putting the first 2 terms in parentheses. Let's take half of this middle term, or this linear term, so I'll do this. -8 divided by 2 is -4, and then when I square that, I get positive 16. So in this problem, what we want to do is take the terms that we separated and put in parentheses, and we're going to rewrite this as x squared minus 8x plus 16. And then we still have that plus 18. But then here's where we do something a little bit different. Since we added 16 to one part of this, we need to subtract 16 from the other part, because essentially now we've added 0. So we're not changing the value of the problem, but we are making it something easier to work with. Now what we have inside the parentheses is a perfect square trinomial. We know it's a perfect square trinomial because half the -8 is 4, or -4. When we square -4, we get positive 16. So we can see now that this the parenthetical terms will factor as x minus 4 quantity squared. And then all we have left to do is to simplify 18 minus 16, which is positive 2. And this is actually our vertex form. So we can indicate our vertex now as positive 4, positive 2. And if you want to verify that graphically, let me pull up the calculator. Remember, we're using Desmos to try to make things easier for everybody so that you all have access to it. So it's x squared, pull up my keyboard here, x squared minus 8x plus 18. So here's our vertex. It indicates that it's 4, 2. And when we go look at our notes, that is the exact same vertex that we did find. So if you're having trouble doing these algebraically, try them first. Try to do them algebraically. If you're not sure, verify it graphically. But go back and forth between the two techniques, graphically and algebraically, to ensure that you're gaining an understanding of how these two things are related. With example 3, we're presented with a little bit of a new problem in that our quadratic term has that negative in front of it. So what I'd like to do with this one is factor out a -1 out of the entire problem, and we end up with this x squared minus 6x plus 5. So if you factor out that -1, you change the value of the, let's I'll factor the negative 1 out in a minute. I apologize. Let's just go ahead and do this just like we did with example number 2. So let's put parentheses around our first 2 terms. Leave our last term alone. And we'll do the same steps that we did before, except now we'll go ahead and factor out that negative. Instead of changing every term, let's just factor out the negative out of the parentheses. So that just means we change all the signs of everything inside the parentheses only. To complete the square for this binomial here in the parentheses, we'll take -6 divided by 2, which is -3. And then we square that and we get +9. So what I want to do is add 9 inside the parentheses here. And since I added 9 on the inside, we would think from our previous example that we would want to subtract 9 from the outside. But in this case, because we have this negative in front of the parentheses, that 9 inside the parentheses will actually end up having a negative sign. So we want to add 9 to the outside as well. And what we get is x minus 3 quantity squared. -5 plus 9 is +4. So we have vertex form. Our vertex for this particular quadratic is 3, 4. And you can go back and verify that graphically if you would like. I won't do it on this example. I'm going to go on and jump to example 4. Before I move on to example 4, I do want to indicate one thing to you guys. I know that this is difficult to learn in this method. I'm absolutely trying the best I can to convey the easiest way to do these problems. You're going to really have to watch these videos very carefully. Don't just watch it, blindly copy down the notes, and hope for the best. If you have problems, email me, send me a message on Remind, ask questions. I do not want you to get stuck. I do not want you to get frustrated. I genuinely appreciate those of you that have already reached out to me and asked questions, have already submitted homework. Just keep in mind, I said that I'm not putting hard due dates on anything. So several of you apparently have not watched the first video because I'm getting several messages saying, when's everything due? There are no hard due dates. I just don't want you to get behind. Work on it at your pace. I realize that during this time off, some of you do have jobs and your work schedules have changed, and you're working a little bit more than you were while we were actually physically in the building going to school. So I'm taking that into consideration. But work on this a little bit at a time. Don't just ignore it completely and then let it pile up. And we get down to a point where we're about to return to school and you have 9, 10, 11 assignments that you haven't touched, and we're getting ready to walk in the building and maybe take a quiz, maybe take a test. Who knows what's going to happen. So just keep that in mind. You guys are welcome to ask questions, though. I just want you to understand that. So when we look at example 4, this one is a little bit different as well. Example 3, we had the negative in front of the x squared. With example 4, we have a coefficient other than 1 that's in front of the x squared. But we're still going to start out this same way. We're going to take our first 2 terms and put them in parentheses. Leave our last term alone. Now we notice on the first 2 terms we have this 2 in front of the x squared. We also notice that 2 will evenly divide -12. So let's factor the 2 out. And this is where we're at this point. So what we want to do with this one is the same steps that we've done before. We want to complete the square of this binomial that's in parentheses. So we'll take that -6 divided by 2 and we get -3. And then we square that -3 and we get +9. So when I do that, I end up with 2x squared minus 6x plus 9, and then I have the plus 13 here. So just like in the last example, before I just go ahead and add 9 to this, we have to keep in mind this 2 outside the parentheses will distribute to that 9, making that a positive 18. So instead of adding 9 or subtracting 9 from the outside, I want to subtract 18, because what we're hoping to do is to make this term and this term go to 0, because we want to add 0. If we don't add 0, then we're changing the value of the function. The 2 distributes to the 9, making it a positive 18. Positive 18 minus 18 will be in fact be 0. So now we have 2 x minus 3, because it's half the middle term, because we've generated a perfect square trinomial right here inside the parentheses. And then 13 minus 18 is going to be negative 5. This is now in vertex form, and we can express our vertex using the values for h and k as 3 and negative 5. And let's see, 2x squared minus 12x plus 13. I will graph that one. We have 2x squared. What was it? Minus 12x plus 13. And I want to check the vertex. I get 3, negative 5 on the graph. And in our notes, we came up with 3, negative 5. So we're actually doing pretty good. I won't go through every example on 5 through 10. I'll hit, let's say, 7 and 8 because the rest of them are all going to be very similar. These will be almost identical to what we've been doing. So for this one, the difference that we have here on number 7 is that we don't have that linear term. We don't have that constant. And like I said before, I made a reference to Caleb Pratt. He said, well, it ain't there. That's going to be the famous quote. So if it ain't there, we can put plus 0, and now we can rewrite this as x squared plus 5x. Put that in parentheses, and then we have that plus 0. Now, do you have to do that plus 0? No. There may come a point where you get so comfortable with these that you can do this without adding the plus 0 on there. But some of you, it's more beneficial to see that so you understand what's going on. So just like we did in the previous examples, we're going to take the linear term, which is positive 5, divided by 2. And in this case, we'll leave it as a fraction. So 5 over 2 will remain 5 over 2. But now we want to square it. And when we square a fraction, we square both the numerator and the denominator. So we get 25 over 4. Now, I know you guys love fractions, but it's just one of those things you're going to have to get used to. So when we go back to our quadratic, we can now write it as x squared plus 5x plus 25 over 4 plus 0. And then for that plus 0, I'm going to add 25 over 4 again, or not add it, subtract it, because we want to add 0. And when I simplify this, my quadratic in the parentheses will just become x plus 5 over 2, because that's half the middle term, squared minus 25 over 4. That's in vertex form. Even though it has fractions, it's still vertex form. So the vertex can be expressed as negative 5 halves and negative 25 over 4. If you choose to put it in decimal form, that's okay as also. You can do that. All right, let's look at one more example. I'm not going to do 11 and 12 either. I want to try to keep these videos short so that I don't lose you completely and just hit the most important parts. So again, with this one, we have a situation where we don't have a constant, so we're going to put Caleb's 0 on there. And we will rewrite this as 4x squared minus 8x, and then plus 0 on the outside. Like we saw in example 4, where we have the 2, Example 8, we have the 4 in front of the x squared. We can factor that 4 out. And we're at this point now. So we can take our linear term, the negative 2, divide it by 2, and we get negative 1. And when we square that, we get positive 1. So we're going to add 1 inside the parentheses. And remember, because of this 4 that's out front, 4 times 1 is 4, so what we need to do here is subtract 4 so that we, in effect, have made these two terms add up to 0. And now we can go ahead and finish the simplification. We have 4x minus 1 quantity squared minus 4. It's in vertex form. And our vertex is going to be 1, negative 4. So that's all you have to do on these problems. Examples 11 and 12, same steps. The only new wrinkle that we're adding in there is finding the axis of symmetry. The axis of symmetry, if you guys recall from I think it was probably the last time we were in class together, is just x equals whatever the x-coordinate of the vertex is. So in the case of example 7, the axis of symmetry can be written as x equals negative 5/2. For example 8, the axis of symmetry is x equals positive 1. So that's how you do the axis of symmetry. That's all you need to do for those. Graph them, use the calculator, use Desmos, graph them, sketch the graph on your assignment, and then you're done. If you have questions, please ask. Don't get frustrated by any of this. You guys already should know me well enough by now to understand that I will do everything I can to help you. You're not going to bother me. Just make sure you're making an effort. That's all I ask. I hope everybody's doing really well. You got plenty of toilet paper, lots of food, and I will be talking to you guys again soon.